Hello, welcome once again. Okay, so in this video we'll be learning about nature of roots. Okay, so why we are learning this? Because as I'll recall you, if I had a quadratic equation ax square plus bx plus c equals to 0, where a is not equal to 0 and say the roots are alpha and beta, the roots are given as minus of b plus or minus under root of b square minus 4ac divided by 2a, where this quantity b square minus 4ac is known as discriminant capital D. Okay, now I told you the quantity inside the root should be non-negative, okay, in order to be defined. All of you are very familiar to this, that the quantity inside the root should be non-negative. Okay, so basically this fundamental thing gives us different things in which we can classify, or which we can demonstrate the different varieties of roots. Okay, so because see, minus b, any real number, it will always be defined. A, we already say that a should not be equal to 0. Okay, hence the denominator is also defined. The only thing that is remaining to be defined is the quantity that is inside the root. Okay, so let us take the first case when d is greater than 0, that is b square minus 4ac is greater than 0. If this is greater than 0, then everything is fine. You will have different roots that are minus b plus of b square minus 4ac by 2a and minus of b minus of under root of b square minus 4ac by 2a. As you can see that both the roots are completely different from each other and they are also real. Hence, when d is greater than 0, we say that the roots are real and unequal. Easy to visualize because see, you're adding a quantity to minus b and you're subtracting a quantity to minus b, then obviously you will have unequal roots. Okay, and since everything is defined inside this, they are real as well as unequal. Second case that we can come across is when d is equal to 0. Okay, that is when b square minus 4ac is equal to 0. Then the roots will become minus of b plus minus 0 by 2a, that is only minus b by 2a. Okay, now everything is this is defined. So in this case I will say that the roots are real, but they are also equal. Okay, that the both the roots are minus b by 2a and minus b by 2a only. Okay, the roots are still 2, but they are real as well as equal. Okay, they have the same values. This case you will get when d is equal to 0. And lastly, the third case is when d is less than 0. What will happen when d is less than 0? This means b square minus 4ac, that is the quantity inside the root, is less than 0. Now you know that anything inside the root should be non-negative. Okay, hence if this is less than 0, it won't be defined. Hence you will have non real roots. Okay, that is not in the scope of class 10th. Okay, so we'll be having non-real roots when d is less than 0. This classification of d greater than 0, less than 0 or equal to 0 is important because this is the major factor which helps you in determining the nature of roots, that whether they are real or equal, whether they are real or unequal, or whether they are not real. Okay, so let me give you some examples that will make this concept more clear. Okay, say for example, if I have a quadratic equation, say 2x square plus x minus 1 equals to 0, and I need to find whether I'll be able to find the roots or not. Okay, so in order to find that, let me find the value of capital D, that is b square minus 4ac. So this is equal to b is 1, so 1 whole square minus 4 into 2 into minus 1. Correct? So this becomes 1 plus of 8, which is equal to 9. Greater than 0. Okay, everything else is defined, hence the roots will be real and unequal. First case. Okay, see, It depends from question to question. If the question only says to find the nature of roots, you don't need to find the roots. You just need to find the value of d, which will tell you about the nature of the roots. Okay. If the question says that check whether the roots are real or not, if they are real, find the roots, then only find the roots. Okay. Otherwise, there is no need to find. Okay. Let me take another example. Say I have, say, x square plus x plus 1 equals to 0, and the question is find the nature of roots. So let me find the value of d. B square minus 4ac. B is 1, so 1 whole square minus 4 into a is again 1 and c is 1. So this I'll get 1 minus 4, that is minus 3, less than 0. Okay, this is the third case and the roots are not real. Okay, so are you getting the point? Yeah, of course, I think you might be getting. Okay, let us take one more example. Say I have the equation 2x square plus 5x plus 5 equals to 0. Okay, so I need to find the nature of roots. So I'll find capital D. B square minus 4ac, 5 square minus 4 into 2 into 5. 25 minus 40, which is equal to minus 15. Correct? Less than 0, hence roots are not real. Hence this finding D is very crucial. This will tell you whether the roots are real, not real, or whatever it is. Okay, let me take another example. See, some questions will be like, they will say that the roots are real and equal and you need to find the value of an unknown quantity. Okay, for example, this was a question asked in your CBSE exam, that it is given that k plus 1 x square minus 2 times k minus 1 x plus of 1 equals to 0. Okay, it is given that the roots are real and equal. So find the value of k. So you know the roots are real and equal, it means d is equal to 0. Okay, and so we will put b square minus 4ac as equal to 0. Let me put the values. Minus of 2 k minus 1 whole square minus of 4 into k plus 1 into 1 is equal to 0. B square minus 4ac. Okay, now let us simplify and see what are we getting. This becomes 4 into k square minus of 2k plus of 1 minus of 4 times k plus 1 equals to 0. 4 and 4, I'll take it out. So finally I'll have k square minus 2k plus 1 minus of k minus of 1 equals to 0. Plus 1 minus 1 cancelled. So k square minus of 3k equals to 0. I'll take out k common. K into k minus 3 is equal to 0. So from here k is either equal to 0 or 3. This is my solution. So now I think you might have a clear picture how to determine the nature of roots and how to solve questions based on that. Okay, so I think your concept regarding the nature of roots is clear, and if you like the video, do like it, please share it, and do subscribe the channel for more updates and more videos. Thanks for watching. Have a nice day. Thank you.